All right, hey class. So in this video, I'm going to talk about the review guide for tomorrow's quiz on quadrilaterals. Yeah. So you already have the other video that you can watch that covers all the homeworks, but this one is just for the one quiz review. So we'll start. I'm going to go through everything. So I'll try to go a little bit fast because I know I did a lot of it in class. But number one just says complete with the definitions of each figure. So a quadrilateral is a polygon with four sides. And that's it. All it takes to be a quadrilateral is that you're a polygon that has four sides. Now if you want to be a rectangle though, then you need to be a quadrilateral with four congruent angles. And of course, if all four are congruent, that means that all four will be right angles. Okay, to be a parallelogram, well, it's right in the name. If you're a parallelogram, then you have two pairs of opposite sides that are parallel. And to be a rhombus, you need to have, a rhombus is a quadrilateral with all four sides congruent. All four sides are the same length. So to be a square, that's kind of a mixture of a rhombus and a rectangle. You have to have all four sides congruent and all four angles congruent. And all four angles. And finally, to be a trapezoid, you just need exactly one pair of parallel sides. And that's it. Those are the definitions of our quadrilaterals. If you can't see it, make it bigger. So there, if you needed to see it, there it is. I'm going to move on. And if you didn't have a chance to copy it all down, just, rewind the video and click pause. Number two. So I remember this problem. There were two ways to do it. Because in every parallelogram, and that's what they said we have here, right, is a parallelogram. Well, there's two different properties here at play. We could take this angle and the angle across from it. These are the opposite angles. And we know those angles will be congruent. But at the same time, we could have taken this angle here, the one that has x in it, and this angle. And then those two angles that I highlighted in green are called adjacent angles or consecutive angles. And consecutive angles always add up to 180. So you have options here. You could write the equation 5x plus 3 plus 127 equals 180. In this equation, you're using the fact that the two angles are supplementary. But you could also write what I think is a simpler equation where you just say 5x plus 3. Well, that just straight up equals 53. And you could solve this orange equation. Let's do the orange one. To solve this, you'll subtract 3 from both sides, canceling it out on the left and leaving yourself with just 5x on the left. And on the right, 53 minus 3 is 50. Then you'll divide both sides by 5. That'll cancel 5 on the left, leaving just x and giving you an answer of 10. So now, just out of curiosity, what if we had set this up the other way? Well, the first thing you would do to solve this is you'd simplify the left-hand side, because I see a 3 and I see a 127, and I can combine those. So this would become 5x plus 127 plus 3, which is 130. That equals 180. So now I can start doing algebra. I'll subtract 130 from both sides to get a 5x that equals, well, 50. And then we're right back where we are over here in orange. If I divide both sides now by 5, I get 10. So you can see that truly, either way we chose to set this up, we get the same answer. And that answer is that x equals 10. So actually, the property that we used, where see here it says what property did you use to find x, it depends on how you wrote your equation. If you did this orange equation, then the property that you used would be the one that says in a parallelogram the opposite angles are congruent. But if you had chosen to write the green equation, then technically the property you used would be the one that says in a parallelogram the adjacent angles are supplementary. So there, let's do 3. So in number 3, you now have to use the rule about adjacent angles. There's no opposite angles here to work with, but that's fine because we just talked about how these adjacent angles are going to be supplementary. So you know that you've got a 7x plus 3, you've got a 9x plus 1. And don't make the mistake of saying they equal each other. Of course they're not equal. These are adjacent angles. So they add up to equal 180. So you get both expressions together on one side of my equation. And of course if I have two different things on the same side of the equation, then I want to simplify them like normal. I've got a 7x and a 9x. Just combine them. That becomes 16x. Then I've got a 3 and a 1. So that becomes a plus 4, and that whole thing now equals 180. So now I'll start doing algebra. I'll subtract 4 from both sides, canceling that out, and getting a 16x that equals 176. Now I can divide both sides by 16, and I'll find that x is 11. And again, the property we used was the same one we just used from the last problem. It's the one that says the, oops, not the opposite angles. We're using the adjacent angles. And we're saying that the adjacent angles, they're not congruent, they're supplementary. All right, that's another question down. For number 4, it looks like for number 4, they've given us this line segment here. They said it's 74. Then they gave us this line segment over here in orange, and they said it's 4x plus 2. And then they're kind of randomly just giving us this segment too, and they're saying it's 50. So looking at the 3 pieces of information they gave me, you guys would have to figure out what it matters here. And it's definitely going to be the pink and the orange, because we know that this diagonal BD, is going to bisect diagonal AC. Bisect means cut into 2 equal parts, right? So we know that in this diagram, the pink segment that they gave us is definitely going to be equal to the orange segment that they gave us. And if you're wondering what do we do with the blue, you literally just ignore the blue. The blue it doesn't help us at all. It has nothing to do with the problem. So we just want to grab the pink segment, which is 74, and we want to set that equal to the orange segment, which is 4x plus 2, and then solve. We'll solve by subtracting 2 from both sides to get a 72 that is now equal to 4x. Then we'll divide by 4 to get an 18, and that's it. X is 18. And so now it's asking, hey, in a parallelogram, what's the rule that we used? In a parallelogram, the rule that we used is that the diagonals bisect each other. All right, what about the next one? Okay, another one. So this is another one that kind of gives us a little bit of extra info. We've got that pink algebraic expression over there. In green, they're telling us that that side is 37. And then down here in blue, they're telling us that this side is 5x plus 4. So again, who matters? Does the blue equal the green, or does the green equal the pink, or does the blue equal the... It's the blue equals the pink, right? I like to think you guys knew that. I think we know by now for sure that the opposite sides of a parallelogram, they're going to be congruent. So this is another problem where we actually can just kind of ignore the 37 that they gave us. We want to stay focused on the opposite sides, which are the blue and the pink. So, okay, grab those expressions, set them equal. So in blue we've got 5x plus 4. And in pink we've got 7x minus 8. And so my preference here when solving is to always start with the x's and start with the smaller number of x's, which is only 5. I'm going to take 5x away from both sides. When I do that, it makes sure that I don't get a negative number of x's. 7 minus 5 is positive 2, which is good. Alright, now I'm going to add 8 to both sides. So the 4 plus 8 will give 12. And the 8 will cancel out, so I'll just have a 2x. Then I'll divide by 2 to get 6. And that's it. X is 6. And what rule did we use? Well, we were talking about opposite sides, right? So in a parallelogram, the opposite sides. And what do we say? We said they equal each other. So I guess that means opposite sides are congruent. That's the property that we used. We can try 6 now. All right, 6 now changes gears. Notice that for 2, 3, and 4, they're telling us you are definitely a parallelogram. Number 3 says, hey, you're definitely a parallelogram. Now solve for x. This one too. You're a parallelogram. Solve for x. Number 5 says, you're a parallelogram. Solve for x. Number 6 is now totally different. It says, hey, I'm telling you this time that x is 4. Now you figure out whether you're a parallelogram or not. And luckily, basically, it's just all the rules we had before. We knew that if we were a parallelogram, then our opposite sides are parallel. We knew that our opposite sides are congruent. We knew that our opposite angles are congruent. And we know that our adjacent angles are supplementary. And we even knew that our diagonals bisected each other. So now, these new kinds of problems are basically saying, hey, you don't actually know that you're a parallelogram, so you can't assume any of these properties. What they want us to do now, basically, is take all these rules and kind of do them in reverse. They want us to decide that because the opposite sides turn out to be congruent, that makes us a parallelogram. Or they want us to show that because the opposite angles end up or because the adjacent angles end up being supplementary to each other, that proves that we are a parallelogram. So we're kind of just doing everything in reverse now. Okay, great. So what does that mean? Well, looking at the figure they gave us, I certainly see a 13 that equals a 13. And that's a pretty good start towards showing that the opposite sides are congruent, because we see a 13 that equals a 13. So now we just have to show that this thing up here, 3x plus 1, that has to equal 10. And we know that x is 4, so it sounds like I'm going to be able to grab this side here, the 3x plus 1, and I'm going to be able to substitute into it this 4. And it turns out that this is 12 plus 1, which is 13, but we needed it to be 10. And it ain't 10. So that means the only conclusion we can draw is that this figure is not a parallelogram. Why not? One pair of opposite sides is not congruent. Because we know that to be a parallelogram, both pairs of opposite sides had to be congruent. So the fact that this guy came out to be 13, that wrecks it. We must not be a parallelogram. Okay, neat. So now what? Now we do 7. Okay, so again we're wondering, is 7 a parallelogram? And I see a 4 and a 4, and that definitely seems to tell me that this red diagonal, again, but this time I don't know what I did. Oh, there we go. Okay, so if those segments are 4 and 4, then that means this red diagonal is bisecting the other one. So this blue guy is definitely getting bisected by the red because his two pieces are congruent, 4 and 4. And I'm sure you're thinking, yeah, Mr. F. The other pieces are the same too, the 5 and 5. So that does mean that the blue one is also bisecting the red. And if we turn back a page, did we say that the diagonals bisecting each other is valid proof that the figure is a parallelogram? And yes, we did say that. So you can therefore conclude, is this figure a parallelogram? Yes. What's your justification? Well, it's because the diagonals bisect each other. Moving on. All right, number 8 is kind of a no-brainer. As long as you remember what these symbols mean. Those little arrows mean that those sides are parallel. And these double arrows mean that these sides are parallel. So I'm not going to spend a lot of time on this one. Are we a parallelogram? Yep. That's literally the definition of a parallelogram, is to have your opposite sides parallel. So our justification is both pairs of opposite sides are parallel. That's it, man. Number 9. All right, 9 is a bit tricky. So one of the rules of being a parallelogram is that your adjacent angles should be supplementary. So if the very first thing you looked at was these two angles, you'd ask yourself, hey, did 95 and 85 add up to 180? And they do. They do add up to 180. So that's one pair of adjacent sides that are supplementary. But real quick, you'd probably look at this pair, the orange and the orange, and 95 and 95 do not add up to 180. 95 and 95 add up to 190. And so that kills it. We can already see that not every single pair of adjacent angles are supplementary. And to be a parallelogram, you need every single pair to be supplementary. So are we a parallelogram? No. Justification, not every pair of adjacent angles are supplementary. All right, and of course, hopefully a bunch of you are thinking, hey, Mr. F, you probably could have just focused in on this 95 and this 85 and said that we're not a parallelogram. Because if the opposite angles are not congruent, then you're not a parallelogram either. So it might have been easier just to say, this guy's 95, this guy isn't 95. That makes us not a parallelogram. But I wanted to point out that there's a little something tricky here, where we do have one pair of adjacent angles that are supplementary, but the other pair is not. And you need all the pairs to be supplementary. Moving on. All right, so 10 is a change of pace. We're not talking about just a plain old parallelogram anymore. We're now talking about a rectangle. And before you hear me wrong, a rectangle still is a parallelogram. It has all the properties of a parallelogram, but a rectangle is sort of an extra special parallelogram, and its extra specialness is two things. We know that in this rectangle, all of its angles in the corner here will be 90 degrees. And the other important difference is that we know the two diagonals will be congruent. So we know that instead of having one long diagonal and one short diagonal, we're going to have a blue diagonal and a green diagonal that are actually exactly equal in length. Those two properties are different. Those two properties are true for rectangles, but they're not true for plain old parallelograms. So if you knew, you didn't need to know the right angle thing for this particular problem, but you definitely needed to know that the two diagonals are the same, because they're telling us that AC, that's the 80, that's the green one I mean, they're telling you that the green diagonal is 80. And that's useful to know, because if the green guy's 80, and if the green and blue have to be congruent, then that means the blue guy's 80. But wait, there's more. Because we knew that even in plain old parallelograms, don't the diagonals cut each other in half? So in a parallelogram, you'd have a short piece with a short piece and a long piece with a long piece. But in this parallelogram, we know that actually all four pieces will be the same, and they'll all be half of 80. So this will be 40, this will be 40, this piece is 40, and this piece is 40. That again is kind of a special rule that's working just because we're a rectangle. But they told us ED is 9x minus 5. Well, ED is half of the blue diagonal. So I'm ready to say pretty confidently that 9x minus 5, it doesn't equal 80, but it does equal half of 80, so it's 40. And finally, we've got an equation we can solve now. So just add 5 to both sides, and you get 45. And now divide by 9, and you'll find that x is 5. That's it. Now to find BD, well, who is BD? BD is the total length of the blue diagonal, which we just said the two diagonals are the same. So since they gave us that the green one was 80, you know that the blue one is also 80. And now they want to know, what's the measure of angle ABC? Well, if I draw a line from A to B, and then a line from B to C, they're asking us for this angle. So I guess I lied when I said we didn't know that the four angles were right angles, because here they are saying, hey, what's the measure of the angle of this rectangle? And of course it's 90. That's the definition of a rectangle, really, is that all four angles are right angles. And that's 10 down. And then 11. For number 11, first thing you have to solve for is x. And this is a little tricky because there's only one x expression. Normally when you solve for x, think back to one of these problems. Normally when you solve for x, you can typically find two x expressions. You can find one x expression in blue, then a second x expression, and often you end up just setting those x expressions equal to each other and solving. But in number 11, the only thing you have is the 2x. And there seems to be nothing to pair that with, right? Until you read that we are a rhombus. And just like how rectangles had a few new properties that parallelograms didn't, well, rhombuses have new properties that parallelograms don't have too. The first and most obvious property is that all four sides are the same length. So the fact that they told you that this side was 13, well, of course you knew that the opposite side was 13, but in a rhombus, you know that everybody's 13, including the adjacent sides. So that's 13 now, that's 13 now too. The other two big things are that, again, have to do with the diagonals. Now the diagonals are not congruent. I would definitely not say that the orange diagonal I just drew is congruent to the green. They're not congruent, but hopefully you're noticing that they are definitely perpendicular. And the fact that they're perpendicular means that that expression, the 2x, well, that's 90, because 2x is talking about the measure of a right angle. So you just divide by 2 and you get 45. And you now know that x is 45. Now for the other big thing about rhombuses. The other big thing about rhombuses and their diagonals is that the diagonals actually bisect these angles. You actually know that because this guy up top is 20, this guy down here is 20. And again, that would not be true in a parallelogram. If I drew a parallelogram where I had very clearly short sides and very clearly long sides, then if I were to draw in a diagonal and tell you that this is 20, I certainly hope nobody out there is telling me that this angle is 20. This angle literally looks like it's more like 100. Oops, more like 100, right? Certainly nowhere near to 20. However, in a rhombus, the diagonal will always cut those angles in half. So I now know that because both of these angles are 20, I know the whole thing is 40. And it's still true. I still have the parallelogram rule that says opposite angles are congruent. So if this guy's 40, then this guy's 40, and the diagonal is still bisecting this angle, right? So 40 chopped in half is giving 20 and 20. So we can see that y is 20. And hopefully that argument made sense. If that argument did not make sense, then there's actually a much easier way to do it. We know that side AB is parallel to CD, because we're still a parallelogram, right? A rhombus is a special kind. Then you could draw in this diagonal. That diagonal now acts like a transversal for us. And so we know that the 20-degree angle and y, you should be recognizing those as alternate interior angles. And alternate interior angles are always congruent. So we actually should have known right away that the 20 and the y were congruent. And that's that. So now to find z. To find z, let me actually get rid of pretty much everything I've done. Because I think to find z, you guys are going to want to see this a little more clearly. So z is this angle right here. And if you focus in on the fact that we've got a triangle up here, then this becomes pretty easy. Because don't forget, these diagonals are perpendicular, aren't they? So you've got the 20, they gave you that. You've got the 90 because we're perpendicular. And don't all three angles of a triangle have to add up to 180? So you know that the 20 plus the z plus the 90 has to give you 180, which means that z plus 110 has to give you 180. And that means that z is 180 minus 110, which is 70. All right, and then the last few angles are kind of cake. It says BCD. Well, if I go from B to C to D, well, actually I already told you that because this is 20 because we got bisected, that makes 40. So that means this whole thing is 40. That was BCD. Now they want ADC. And if I go from A down to D up to C, then I probably want to think back to Z. We said Z was 70, right? So if this is 70, then this whole guy is 140. That means this guy down here is 140. Which actually, we probably should have known, maybe a little more easily, because we know this angle here and this angle here are adjacent angles in our parallelogram. They have to be supplementary. So as soon as we knew that this guy was 40, we could have just done 180 minus 40 to figure out that this other guy was 140. But there's always more than one way to do this thing, so it's fine. Now they want to know AD, and I'm running out of space again, so just move that over there. And so who's AD? AD is this side. So this is another easy question. Unless, if you're not careful, if you didn't read where it said rhombus and you just thought we were a parallelogram, then you would know that this guy being 13 means that this guy is 13. But you might be waiting for this side to be something else. Because in a parallelogram, this side would be something else. But we're not a parallelogram, we're a rhombus. And that means everybody is 13. So, that's it. 13. And then BD. BD is just the other diagonal. So how do I find that? Well, BD goes from here to here. And they told me this chunk was 5. And I know my diagonals bisect each other. So if this half is 5, this half is 5. And that makes the whole thing 10. And there you go. That's your whole review sheet, I think, right? 11 was the last one. Yep. So I'm glad you watched this video. Hopefully you got a lot out of it. If you didn't finish all 5 homework assignments, remember you're skipping the last 2 homeworks. Then you can watch the video where I talk about all the homeworks and try to get a little more help. That's it. Good studying. I hope you do well tomorrow. See you then. Bye.